Hello everybody, my name is Ethan. Welcome back to the channel where today we are jumping back into the machine learning course on Codecademy. In the previous video, we started the Learn Get 2 module. So this is our second time in this machine learning course going back to Get and GitHub. We learned a little bit about Markdown as well. If you missed that, previous video is going to tell you about that. If you missed the other Git and GitHub videos, those will also be in this playlist. So they would have been previous videos. So if you missed those, go check them out. Today, we're going to finish this section. It shouldn't take too long, but basically what we are doing is Git teamwork. So let's just jump right into it. I think that's the best way to do things. Overview. So far, we've learned how to make Git work as a single user. Git offers a suite of collaboration tools to make working with others on a project easier. Imagine you're a science teacher developing some quizzes with Sally, another teacher in the school. You're using Git to manage the project. In order to collaborate, you and Sally need a complete replica of the project on your own computers, a way to track of and review each other's work, a way to keep track of, and review each other's work, and then access to a definitive project version. You can accomplish this by using remotes. A remote is a shared Git repository that allows multiple collaborators to work on the same Git project from different locations. Collaborators work on projects independently and merge changes together when they're ready to do so. Okay, so previously in the other videos, you'll notice a lot of our Git information that we've learned about is all just single stuff, making branches that you yourself change. Now we're getting into some other stuff where we're going to be, doing some collaboration. So let's get into it. Git clone. Sally has created the remote repository science quizzes in the directory curriculum, with which teachers on the school's shared network have access to. In order to get your own replica of science quizzes, you'll need to clone it with git clone remote location clone name. In this command, remote location tells Git where to find the remote. This could be a web address or file path such as /user /teacher /document /some remote. Clone name is the name you want to give to the directory in which the Git will clone it, right? So the Git remote Sally started is called Science Quizzes. Enter the command to clone this remote. Name your clone My Quizzes. So we can do this by doing git clone. We'll do science-quizzes, and then we'll call it My Quizzes, right? When we enter this, we see something that says cloning into My Quizzes, ... And then we also see done. It says Git informs us that it's copying everything from Science Quizzes into the My Quizzes directory. My Quizzes is your local copy of the Science Quizzes Git project. If you commit changes to the project, Sally will not know about them. And that makes sense. Okay, Git remote -v. Nice work. We have a clone of Sally's remote on our computer. One thing that Git does behind the scenes when you clone Science Quizzes is give the remote address the name origin so that you can refer to it more conveniently. In this case, Sally's remote is origin. You can see a list of Git project remotes with the command git remote -v. If we do that, we can do git remote -v, and it says fatal, right? Not a Git repository or any of the parent directories.git. Change directories into the My Quizzes directory. Remember, we can always do the cd command to change our directories, and it wants us to put ourselves in the My Quizzes directory. We should now be in that directory. To learn more about cd, take a look at the command line course, which if you missed that, that was another thing that we talked about in some of our videos. So typically my titles are pretty helpful and indicative of what we cover in that topic. We can now retry to enter git remote -v to see if now we can see some other stuff, right? It lists all the different remotes within the directory. So we have the output origin with this and origin with this. Git lists the names of the remote, origin, as well as its location. Git automatically names this remote origin because it refers to the remote repository of origin. However, it is possible to safely change its name. The remote is listed twice, once for fetch and once for push. We'll learn about these later on in the lesson. All right, git fetch. After you've cloned science quizzes, you had to run off to teach a class. Now that you're back at your computer, there's a problem. What if, while you were teaching, Sally changed the science quizzes Git project in some way? If so, your clone will no longer be up to date, right? So an easy way to see if changes have been made to the remote and bring changes down to your local copy is with git fetch. This command will not merge changes from the remote into your local repository. It brings those changes on to what is known as a remote branch. Learn more about how this works below. So it wants us to first change directories back into the My Quizzes directory. And now it wants to fetch any changes that she may have made. So we can do this by doing git fetch. And when we do this, we can see that possibly 5 objects were different. It doesn't really exactly say, and that's okay. We can keep moving on here. Git merge. Even though Sally's new commits have been fetched to your local copy of the Git project, those commits are on the master/origin branch. Your local master or main or origin branch has not yet been updated, so you can not view or make changes to any of the work she added. In lesson 3, Git branching, we learned how to merge branches. We'll use that git merge command to integrate origin/master into your local master branch. The command git merge origin/master will accomplish this for us. So in the command, again, wants to ensure that we are in the My Quizzes. Oop. It says no such file or directory. Did I spell it wrong? I think so. You're on the local master branch in your commit history. The commit message of head is add first question to physics quiz. From the terminal, merge with origin master where Sally's most recent commits are. Notice the output. Okay, so it just wants us to merge, right? So we can just do git merge origin/master. When we look at this, we can see fast forward, biology.txt, 4++++, one stage, one file change, 4 insertions. Git has performed a fast forward merge, bringing your master. Yep, print the commit history. We can do that by just doing git log, right? So in the output, notice that the head commit has changed. The newest commit should now be add heading and comment to below biology quiz, which is exactly what we see right here. All right, Git workflow. Now that you've merged origin/master into your local master branch, you're ready to contribute some work of your own. The workflow for Git collaborations typically follows this order. First, we fetch and merge changes from the remote, create a branch to work on a new project feature, develop the feature on your branch and commit your work, fetch and merge from the remote again in case new commits were made while you were working, and then push your branch up to the remote for review. Step 1 and 4 are a safeguard against merge conflicts, which occur when 2 branches contain file changes that cannot be merged with the git merge command. Step 5 involves git push, a command you will learn about in the next exercise. So first it wants us to do and ensure that we are in the correct command, right? So we can now enter the command git branch, and then branch name, we'll call it DMX branch. Oh, it wanted me to name it. Gosh darn it. Git branch. We can get rid of it by doing nice. We deleted the branch. Now we can actually create the branch that wants us to create. I guess I was a little too hasty. It wants it to be called bio questions. And I am sorry, I started this video, and as soon as I start the video, as soon as I click play on my video recorder, the guy outside decides this is the perfect time to whip out the wind blower, or the leaf blower, I should say, and go absolutely ham. So sorry about that, but we're just gonna have to continue on. So now we can switch to the new branch by doing git checkout bio questions. So we're now on that branch. On your branch, open the file biologically.txt under the my folder or my quizzes folder in the code editor. Make sure you're editing the correct bio text. So we can do that by just opening. It says it was in the my quizzes. If we go to here, we are now in the biology quiz. Add a biology question to the file and some sample answers. So we can do that by saying, what is an animal that hunts and eats other animals called? So we have A, herbivore, B, prey, C, ecosystem, or D, predator? Great question. So we've added it. We can now add it to the staging area by saying git add biology.txt. It's now been added to the staging area. We can now commit it by saying git commit -m and say add question 1 to biology.txt. And I didn't. I always hit the wrong one. Add question 1 to biology.txt. There we go. Yes, I did, of course. Is that not what I did? Did it give me a different error? Git commit -m add question. Okay, let's just replace the solution because that's exactly what I'm doing. And we're all right. Let's keep going. All right, git push. Now it's time for us to share our work with Sally. The command git push origin your branch name will push your branch up to the remote origin. From there, Sally can review your branch and merge your work to the master branch, making it a part of the definitive project version. So we'll start off by saying, yes, we are in the My Quizzes directory. We can now do a git push origin, and then our branch name was bio questions, right? And we can see that we have this output here. It says in the output, notice the line to, right? Git informs us that the branch bio questions we push up to the remote. Sally can now review your new work and merge it onto the remote's master branch. Cool. All right, generalizations. You can now know enough to start collaborating on Git projects. Let's review. A remote is a Git repository that lives outside of your Git project folder. Remotes can live on the web, on a shared network, or even a separate folder on your local computer. The Git collaborative workflow are steps that enable smooth project development when multiple collaborators are working on the same Git project. We also learned that the following commands: git clone, git remote -v, git fetch, git merge origin/master, and git push origin with the branch name. Up next, we probably have a couple of different things to go through. We have first a project. It's called JavaScript Homework. Let's keep applying the Git collaboration skills we're learning. So there is a remote called Mary Rose -h, which contains, or Mary Rose Homework, I guess I should say, which contains your students' JavaScript homework. Clone the remote and give it a name of your choice. Okay, so we can do this by doing git clone origin. I believe it's git clone. Oh, well, actually, it's the name. So it's Mary Rose -HW, and then the name of our branch, giving it a name of our choice. So we can call it Mary Rose clone. And we have cloned it. In the CERM, yep, so now we can do cd Mary Rose underscore clone. CD Mary Rose underscore clone, not close. So now we should be in there. Use the file navigator to open homework.js in the code editor. Be sure to open in your clone, not the remote. So we'll open up this in the clone, right? We have done that. And from the terminal, create a new Git branch. Your branch will be commenting on Mary Rose's JavaScript homework, so name the branch appropriately. So we can do that by doing git branch and then the new branch name. We'll just call it Mary, oh, no, we'll call it, sorry, Mary Rose comments. So we've created a new Git branch. Switch over to the new branch. So we can do that by doing git checkout Mary Rose comments. Time to start commenting on Mary Rose's JavaScript homework. Comments are used to leave notes for other programmers or yourself. In JavaScript, you can make a single line comment by typing / at the beginning of any line, then type your comment. For example, I'm a comment. So we want to just write a comment anywhere. We'll write, very good job, DMX monkey. So we've created our comment. We're now going to add our changes to the staging area. So we'll do that by saying git add homework.js. And then it wants us to make a commit. So we'll say git commit -m and add the message of add comment to homework. And we have now added that commit. We want to push now our branch up to the remote. We can do this by doing git push. And then I'm actually wanting to wonder what that one actually is. I think it's git push and git push. Push your branch up to the remote. Oh, no, I was saying, okay. So git push, and then if we try, let's just try, I think it was origin / master. Oh, and that is not good. Okay. So git push this current Mary Rose oh boy. Git push Mary Rose. What is it called? Mary Rose Mary Rose -HW. What am I doing wrong here? Let's quickly take a peek. It's going to load slow. What is the quick git? I'm forgetting a little bit about the git push here. I wish it actually opened it up. It didn't do that, unfortunately. Yeah, it was the last thing that we kind of looked at here. Git push, there we go. Git push origin branch name. Cool. And we are back. Open that back up. So now we can do git push origin and then the branch name, which in this case was Mary Rose comments. which I think is what we did. And now we can do cd .. Mary Rose homework. Change it. Use your get knowledge to see the branch you just pushed. CD branch or get branch. What was the command to viewing all branches? Get. It's not a log. Get branch something. Let me just quickly look it up here. Get command for viewing all branches. Remote. Why isn't it just saying it? Get status. That's what it is. I remember now. Status. That's not going to help. CD data. So get. All right, that was a little bit of an interesting project. I don't know how much I like that one. I don't feel super confident for that one. But let's try a different one here. Hopefully we do a little bit better. Go into the veggies remote by using the cd command. Cd veggie favorites. All right, we're inside. Make a change to chili or squash. We'll get rid of the S there. We'll get rid of another third. 2 can of one type of bean instead of beans. Why not? We click save here. We're going to add our thing to the staging area by saying get add chili.txt. And then we can say get commit minus m and have the message change beans to bean. Cool. Okay. Go into your clone with cd .. veggie clone. We're now in the veggie clone. Fetch all new work from the remote. Oh boy. What was that called? What was that one? I'm struggling, I guess, a little bit. Why isn't it letting me like check all the different little files under it? It's a little annoying because now it's going to let me get clone fetch. Get fetch. So now that we're in the correct one, we can do get fetch. And now I think it's probably mad at me because I didn't. So okay, there we go. Merge origin master, so we can do get merge origin into your local master branch. Okay. Create a new branch. So it wants me to create a new branch, get branch, new branch, get checkout, new recipe, DMX, monkey soup, ingredients, Okay. We can now do a git add new recipe.txt and then do git commit. Fetch one more time for good measure. We can do that by doing git fetch. Push up your branch. So this again, we're going to remember how to do this command. It's git push origin branch name, which would have been new branch. Got it. Navigate back up with cd .. veggie minus favorites. Confirm the presence of your new branch back there. We can do that by going to git status. See, that's what I thought. I think there's a different one. Git command view all branches. Git show. It might be git show. Git show. Yikes. It's like the log. I'm going to just quickly try and find it so that you guys know it. Git branch minus R. Might be that. Git branch minus. Nope. Okay, we're just gonna move on. Sorry about that. Which command merges the origin into the local master? Yep. What piece is missing from the command down below? The name of the branch. What does git fetch do? Fetches new commits made on the remote branch and then merges them. Yep. What is a remote? A Git repository that allows multiple collaborators, an independent Git project where merges. Yep. Of which command git remote minus v, which is true about the command below, git clone remote location. The clone will not be connected to the remote. The clone clones a Git project. One of these? I guess a commit. After cloning a remote, what is the next step in the Git collaborative workflow? There's some more information here about deploying to GitHub pages. GitHub is a great tool to store projects and to collaborate with others, but its usefulness does not stop there. We'll talk about a service called GitHub Pages to share our web page creations on the World Wide Web. So if you're worried about wanting to use GitHub to do some stuff on the internet, actually, there's some stuff here for you, and I assume that's what the this project is, because this one is an off-platform project. So I'm not going to worry about this one, actually. So it wants me to download a bunch of stuff. I'm not really worried about downloading stuff like that. I don't want to. Typically off of websites like this, but we can continue on. Not saying anything bad about Codecademy. And then here's the solution to it, of course, if you need that. That is probably going to do it for today. We are going to get into the intermediate machine learning course, which I'm very, very excited about, in the next video. But if you did enjoy, please be sure to leave it a like, subscribe, and I'll see you in the next one. Peace out.